Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present our assignment project, which is the title is pressure in pipe. So we are from BMMA S2/1. So here the name of our member. First is RIZMANHADI bin NASRIL. Third is me, Muhammad Harith bin MAJID. And fourth is Muhammad FARIS bin ZULKIFLI. Okay, next one. So next is the introduction. So first is fertigation is one way of growing advantage of minimizing amount of watering. Second is two types of pipe configurations may be applicable for the watering process, namely straight line or closed loop. And the third is these two different configurations will give variation in terms of flow rate as well as the volume of water received by each plant. And the last is dissertation later will affect the quality of the plant itself. Next. So the third one. So we go to the objective. The first objective is to perform experimental flow exercise in hose pipe. And the second one is to analyze pressure variation in hose pipe over a specific pipe length with two different configurations. And the last objective is report the findings in an appropriate approach. So next we go to the list of items for both fertigation system configuration. So the first item is 3 or 5 millimeter diameter single connector. The quantity is 10. And the second item is 16 millimeter T connector. The quantity is 1 only. The third one is 16 millimeter times by 10 meter hose pipe. The quantity also is 1. And the fourth is 5 liter measurement tank. The quantity is 1. The next is hose clip. The quantity is 10. Next, the last item is stopwatch, and the quantity is only 1. Next, I will give to RIZMANHADI to continue the presentation.
Okay, thank you, Harith. Okay, I will explain about the straight line water hose configuration. Okay, for the straight line water hose, we set up hose pipe, which is 60 meter time 16 mm time 10 mm. Okay, second, use single connector to fit minimum of 5 holes at equal distance. Number third is block the end pipe. Fourth, ensure the whole pipe on the same level. Fifth, open tap up to maximum and measure the flow rate or velocity at each hole in once over the same period. Okay, the last is record the data properly. Okay. Okay, this is for closed loop water hose configuration. Okay, the first one is set up hose pipe. The second, use T connector 16 millimeter T connector to make it closed loop. Also use single connector. Okay, third, ensure the whole pipe on the same level. And fourth, open tap up to maximum and measure the flow rate velocity at each hole in once over the same period. Okay, the last one is record the data properly. Okay, for the calculation, there are 3 situations that has been studied in this experiment. Okay, the first one is involved is only a water hose. The second one is the straight line water hose configuration, and finally, the third one is closed loop water hose configuration. For each situation, we determine the height of the water jet and time taken to fill 5 liter water tank. Okay, that's all for me.
Okay, so for situation 1, which is involving the tap and the hose only, we need to find the pressure in the pipe. So by having the maximum water jet height, which is Z2, we get 2.15 meter, and the time taken to fill 5 liter of water is 40.6 second. Okay, next. So from situation 1, we can use the Bernoulli equation to find the maximum pressure P1, which is the pressure in the host. And there are a few things that we can sort out. First, the velocity inside the host are negligible because it's too small compared to the velocity of the jet water. And then second, Z1 are considered 0 because it was at reference point level, which is on the ground. And then at the top of the water trajectory, V2 is equal to 0 because the water only got to 2.15 meter. And then P2 are equal to the atmospheric pressure. And by using the Bernoulli equation, we can put in the value, and then we get pressure for P1 is 122,416.5 Pascal. Next. Okay, after we have the flow rate which is the Q, then we can find the velocity of the water. And then we can use the formula which is V equal to 4Q over pi D square, where Q is flow rate and D is the internal diameter of the water hose. Next. Okay, so for the straight line water hose configuration, we perform the same method of calculation with the flow rate. For the flow rate and the velocity, the flow rate we use the equation volume over time, which is we have for each calculation we use 5 liter, and then the time is for number 1 is 213.14. For number 2 is 215.45. Number 3, 236.24. Number 4, 266.44. And then number 5 is 266.161. By using the equation flow rate Q equal to volume over time, we get this number lah, which is 0.0236 times 10 to the power of -3, and then we get the velocity of 0.08274 meter per second. And then we use the same method for all the hole in the straight line water hose configuration. And the number 1 is the nearest to the pipe, and number 5 is the furthest from the pipe. Next. So for the closed loop water hose is also the same way of calculation like the straight line water hose configuration. We have the time for each of the hole, the time taken to fill 5 liter of water, and then we have the flow rate, which we can calculate using the flow rate equation, volume over time, and then we get the velocity using the flow rate. The equation for velocity, which is 4 times flow rate over pi times diameter square. So in this particular case, the number 1 and then the number 10 is the nearest to the pipe. The only difference is number 1 is the nearest to the pipe from the right, and then hole number 10 is the nearest to the pipe from the left. Okay, I let Muhammad Faris to continue the presentation.
Assalamualaikum. My name is Muhammad Faris. I will continue this session. So in configuration 2A, we found that the hole 1, which is the nearest to the tap, have the highest velocity compared to the other hole, and hole 5 has the lowest of all. This is because of the higher pressure that exerts from the tap at hole 1 and gradually decreasing due to the pressure that released to the atmosphere from the hole itself. In configuration 2B, however, is a bit different. In this configuration, water are circulating in a closed loop, but the water flow from the tap through T connector make the water slip into two directions, left and right. At this point, the pressure in the pipe and the velocity of the water act the same as in configuration 2A, which is the nearest hole from the tap itself, have high pressure and velocity compared to the furthest. In this case, hole 1 and hole 10 are the nearest, contrary to the hole 5 and hole 6, which is the furthest. So, for the conclusion, we are able to perform the experiment flow in the hose is success. We are able to deduct the pressure in the pipe and the velocity of water in each and every hole on the hose pipe in any configuration given by identifying the flow rate of the water. Also, in this experiment, we can summarize that pressure and velocity are directly proportional to the velocity. The higher the pressure, the faster the velocity. That's all from us. Thank you.